Hello, okay, here is a hopefully quick few examples on how to calculate the regression line on a scatter graph or the line of best fit. So you need to be able to find the equation of a least squares regression line, either by using the raw data or by using summary statistics. So the basic equation is y equals a plus bx, where b is sxy over sxx, and a is equal to y bar minus bx bar. SXY and SXX are known as summary statistics, and you can calculate them using the formula below. So SXY is the sum of XY minus the sum of X times the sum of Y over N. So N is however many pieces of data you have. SXX is the sum of X squared minus the sum of X all squared, again over N. Those two formulas are very similar in that if you replace all of the y's in SXY with X, then you would get SXX, if that makes sense. And then obviously SYY is the same as SXX, just with y's in instead of x's. And we're going to use those to be able to calculate the regression line. So here's an example. You have the results from an experiment in which different masses were placed on a spring and the resulting length of the spring measured are shown below. So we've done that with 5 different objects with different weights, and we have saw how far the spring will stretch. Now, using a little bit of common sense can kind of help you check that you are on the right path with this question. So it makes sense that the heavier the object is, the further the string is going to stretch. The spring is going to stretch. So it should have a positive correlation, which means your gradient or your B value for the regression line is going to be positive because it's going to have a positive correlation. As one is increasing, so is the other. So part A, calculate SXX and SXY so that we can use them to calculate the equation of the line. So SXX is the sum of x squared minus the sum of x all squared over n. So in this case, we've been given some of the, what is the word I'm looking for? We've been given some of the numbers that we need. So sum of x squared is 22,000. The sum of x is 300, and then we're squaring that and we're dividing it by 5 because we have 5 pieces of data in the table. So we're doing 22,000 minus 300 squared over 5, close my bracket, gives me 4,000. So SXX is equal to 4,000. SXY is the sum of XY minus the sum of X times by the sum of Y over N. So sum of XY is 18,238 minus sum of X is 300, sum of Y is 288.6, and we're still dividing by 5 because there are still 5 pieces of data. And that gives us 238 minus, put it into a fraction, times 288.6 divided by 5, close my bracket, gives me 922. Okay, so those are my summary statistics, and then I can use that to get the least squares regression line. Bit of a mouthful to say, especially after a long day. Okay, part B then is calculate the regression line of y and x. So I've wrote the two values of SXX and SXY at the top there. So here's one I did earlier. So your regression line is y equals a plus bx. B is equal to SXY over SXX. So 9 SXY over SXX. So that is 922 over 4,000, which is 922 over 4,000 is equal to 0.2305. That is our gradient, that's our B. A is equal to y bar minus bx bar. Y bar is 57.72. B is 0.2305 and x bar is 60. Yeah, so times that by 60. That gives us 57.72 minus 0.2305 times 60 is 43.92. That is our A. So the equation of our line is y equals 43.92 plus 0.2305x. And that is our regression line equation. We can use that to predict different lengths of the spring depending on what mass we've been given. We couldn't do it the other way. We couldn't work out the mass given the length of the spring. It doesn't work that way, but we can use this line to predict the length of the spring. So again, I've copied my, what have I done there? I've made a mistake. Now which one's wrong? I've got a slightly different A value here. Let me just check it. 57.72 minus 0.2305 times 60. Yeah, I've typed something in my calculator wrong. That should, that's too big. I'm always so professional when I make these videos, aren't I? It should be 43.89 plus 0.2305x. That is the equation of our line, and we are going to use that to predict the length of the spring when we are given different weights of the object. So for part I, we are using 58. The mass is obviously our x value, so we are working out what y is by doing 43.89 plus 0.2305 multiplied by the mass of 58. That gives us a length of the spring that is plus 0.2305 times by 58 is 57.259. I'm not going to bother rounding, I'm just going to leave it as it is. So that is our length of the spring when the weight is 58. If the weight is 130, I'm going to put it into the same equation, 43.89 plus 0.2305 times by 130. That gives me, can I just delete that, put in 130, is 73.855. Obviously those are the lengths, so these are both centimetres. Just to be, make sure you've covered all the bases, make sure you put a unit in there. Part D is to then comment on the reliability of your prediction. So we've got two there. The first one, we were putting in the mass of 58. That is within the range of values that we've been given. So we've kind of gone between 20 and 100 on the actual experiment that we've done. So we can be quite confident that that is an accurate enough prediction for a object of mass 58, because 58 is within that range of values. Whereas 130 for part 2, that goes above what we've actually observed. So we have done an experiment. We have only used values between 20 and 100. 130 is outside of that range, which means we would be using extrapolation, which means that it does not give as accurate a prediction. something strange might happen at like 110 kilograms. We just don't know. So we are using extrapolation, which then means our predictions become less accurate. Something strange might happen. We just don't know. We haven't observed it. That is what you would write for part D. I'm not going to write it down because you don't want to try and watch me just write things onto the screen. But that is what you would write for part D. Right, the next question. I haven't read this question yet. A scientist working in agricultural research believes that there is a linear relationship between the amount of food supplement given to hens and the hardness of the shell of the egg they lay. Okay. As an experiment, controlled quantities of the supplement were added to the hen's normal diet for a period of 2 weeks, and the hardness of the shells laid at the end of this period were then measured on a scale from 1 to 10 with the following results. Okay. It's an interesting scale for the hardness of a shell, but there we go. These are the results. So it would appear, looking at the raw data, that the more of the supplement they were given, the harder the shell. So, it appears to be a positive correlation. The more the supplement they take, the harder the shell of their egg is. Find the equation of the regression line. So we need to find SXX, SXY, A, B, and then pop it into our equation of the line. So, let's just make sure if we're doing SXX and SXY, we don't have X and Y here. We have F and H. F is our controlled variable. They're controlling the amount of the supplement they're given. So this is our X. And then H is the dependent variable. So H is Y. I'm going to just continue using X and Y because habit. So I'm going to find SXX first. So that, again, just to remind you, that is the sum of X squared minus the sum of X all squared divided by the number of pieces of data. So sum of X squared is the sum of F squared, which is 560, minus the sum of F, 56 squared, divided by how many? 1, 2, 3, 4, 5, 6, 7, divided by our 7 pieces of data. Or 7 hens, I guess. Work that out, gives us SXX. Sound like I've got a lisp. I do have a little bit of a lisp, to be fair, but this makes it worse. 560 minus 56 squared over 7 is 112. SXY is the sum of xy minus the sum of x times the sum of y over n. So sum of xy is 422.6. The sum of x is 56. The sum of y is 45.8. We still have 7 hens. 422.6 minus 56 times 45.8 over 7 is 56.2. That is SXY. So to work out B is, let me remember which way around it is, SXY over SXX. Yeah. SXY over SXX is equal to 56.2 over 112. Over 112 is, a really long decimal. 0.501. I'm going to put 4 decimal places. Let's say round that up to an 8. So that is our B. A is y bar minus bx bar. Y bar is 6.543 minus 0.5018, which is our B, multiplied by X bar, which is 8. Times that by 8. And then do 6.543 minus answer is 2.5287. Again, I'll keep 4 decimal places for A. So that means our equation is y equals which one's A again? 2.5287 plus 0.5018x. Interpret what the values of A and B tell you. That there is a positive correlation because our value of B is positive. The gradient of the line would be positive. What is A telling us? It's telling us that there are no shells with a hardness of less than 2.5-ish. Which makes sense. You don't want a hardness of like 1. Otherwise, when you pick it up at the supermarket, it's going to smash before you've even got it home. I'm not sure what else they're asking you for on that question. I am going to really quickly just check what the mark scheme says so that I'm not telling you the wrong answer. But obviously the gradient is positive, so it's a positive correlation. Nope. Sorry, give me just one quick second. This is chapter 5. This is... Oh, it's an example. Uh-oh. Imagine, no. This is absolutely terrible professionalism on Masters Maths. I do apologise, but you know, most of you know what I'm like by now. Example number 6. Where are you? Okay, A estimates the shell strength when no supplement is given. Yeah, okay, so I was right. So when A is when no supplement is given, when F is 0. So there are, even if it has no supplement, then it's still got a 2.5-ish hardness rating, which again makes sense. You wouldn't want them to be really, really soft. 0 is only just outside of the range of F, the range of the supplement given. So it is reasonable to use that. It's quite accurate. 0 is quite close to 2, especially in relation to the size of the range that we've used. We've gone all the way up to 14. So 0 is close enough to 2 that we can be quite sure that a value of 0 for F would give us a hardness of around 2.5. B estimates the rate at which the hardness increases. So it's a gradient, the rate of change. It is also positive, so it means there is a positive correlation. So in this case, for every extra 1 gram of food supplement per day, we're increasing the hardness by about 0.5. So for, if we put X as 1 into here, then every time you are increasing X by another 1, you are increasing the hardness of the shell by another 0.5 on that scale. Okay, so that's that. And then the very last example, if you are still listening, I don't blame you if you're not. A repair workshop finds that it is having a problem with a pressure gauge it uses. It decides to have the gauge checked by a specialist firm. The following data were obtained. The reading is giving you, so this is the faulty gauge, and then on the correct gauge, it's giving you something else. Show that SXY is 6.776 and find SXX. Okay, so part A. I'm only going to do part A and B because I'm not going to draw a scatter diagram. But in fact, we will just skip part C. We won't draw the diagram, but we will use the regression equation to predict for 2 bars. Okay, so SXY is equal to the sum of xy minus the sum of x times the sum of y over n. They have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, so n is going to be 8. Sum of xy is 52.04 minus 19.2 times 18.86 divided by, what did I say, 7? No, 1, 2, 3, 4, 5, 6, 7, 8. I counted 7 the first time, didn't I? Counted wrong. Which again sums up the kind of day that I have had. 52.04 minus 19.2 times 18.86. Divide that. Ooh, I don't want to square it. Divide that by 8. Gives you SXY is 6.776. SXX is the sum of x squared minus the sum of x all squared over n. Sum of x squared is 52.8 minus 19.2 squared divided by 8, which is 52.8 minus 19.2 squared over 8 is 6.72. Okay, we've done that. Part B, we are going to work out the linear regression equation. So B, we need to find the value of B, is SXY over SXX. I don't know why I wrote that S so small. So 6.776 divided by 6.72. 6.776 divided by 6.72 is 1.0083 recurrent. 0.00, I'm just going to put 83 because that's 4 decimal places. A is y bar minus bx bar, which is, oh no, we don't have y bar and x bar. We're going to have to work them out. Oh no, and my Apple Pencil's low. I can work that out quite quickly, can't I? Y bar is the mean of y, right? So we're going to do 19.2 divided by, this would be x bar, divided by 8 is 2.4. And y bar, what's my b again? 1.0083. We're going to times that by 2.4 for y bar, for x bar. Y bar is 18.86 divided by 8. It's 2. Oh goodness, I haven't left myself enough room. 2.3575 minus that. Again, I just want to check that I'm doing the right thing. I do doubt myself. Yeah, I am doing the right thing. And that gives us an A value of 1.0083 times 2.4 is negative 0.06242. Let's leave that as it is. So the regression line, or given your answers to 3 significant figures. Okay, so our regression equation is y equals negative 0.0, 3 significant figures, 624, plus 1.001. No, that's wrong. 1.01 when we round it to 3 significant figures, x, and that is our regression equation. We're not going to do C, but you would draw the scatter diagram, and then you would need to draw that line, and you would need to draw it accurately. So you would need some graph paper, you'd need a nice scale so that you can draw it as accurately as possible. But yeah, your gradient is 1.01 and your y-intercept is negative 0.0624. Not so pleasant. Right, and then D, the gauge shows a reading of 2 bars. Use the regression equation to work out what the correct reading should be. I'm going to try and squeeze that up here. So our regression equation is y equals negative 0.0624. I'm adding on 1.01 times by 2 because we're doing a prediction for 2 bars, which would give us minus 0.0624 plus 1.01 times 2. 1.9576 is our final answer. Okay, I'm going to stop there. So I hope that makes a little bit more sense. Basically, you need to know your SXY and your SXX summary statistics, and you'd be able to substitute values into those. Obviously, sometimes you're given some of the sums there for you already. Sometimes you're not. You know, this time we had to work out X and Y bar ourselves by finding the mean, but you have already got the sum of all of your X values, so you just needed to divide by the number of values you had to get the mean. Yeah, I hope that makes sense. Yeah, I hope it makes sense. I hope it helps. Have a lovely day. Thank you for watching if you have watched all the way to the end.